I'm going to show you how to solve for the integral of square root of 1 plus sine x dx. So we know that there's no direct identity here, so what we're going to do is to multiply square root of 1 minus sine x over square root of 1 minus sine x, just so we could get some identities. So from here, we're gonna multiply this, then we would obtain square root of 1 minus sine squared x dx. So that would be the difference of two squares from here, all over square root of 1 minus sine x. So we can see that there's an identity here. 1 minus sine squared x is just equal to cosine squared x. So performing the square root of cosine squared x, that would be equal to cosine x dx. So this is what we get. So we're gonna let u be 1 minus sine x to make our lives easier. So du would be, so the derivative of 1 is just 0, 0 minus sine x. The derivative of sine x is cosine x dx, so that would give us negative cos x dx. So from that, we're going to substitute that to the original equation. That would give us negative du all over square root of u. Rewriting that would be negative integral of u raised to negative 1/2 du. So performing the power rule, we would then get negative, there's negative here, bracket, u negative 1/2 plus 1 divided by negative 1/2 plus 1 plus c. So performing this would give us negative 1/2 plus 1 is 1/2, negative 1/2 plus 1, 1/2 plus c. So we're going to rewrite that, and we're gonna get negative 2 u raised to 1/2 plus c, or negative 2 square root of u plus c. So we're going to undo the u substitution, since we know that u from here is equal to 1 minus sine x. We're gonna plug that in. Negative 2 square root of u, that's 1 minus sine x plus c. So from here, we could now get the final answer, and that is negative 2 square root of 1 minus sine x plus c.